Hello, and welcome back to another video in the RPG Stat series. Today we will implement the Stat class, which is a class that does not contain modifiers and instead contains other stats. We will start with an abstract version. It will also be a generic class, and it needs to implement our iStat interface. For private class variables, we need an array of stats, and we want to leave the option open that this could be any kind of stats. So we'll make an array of our interface type iStat. We also need a boolean for the dirty flag and two floats for base value and current value. We need to implement the onValueChanged event, and we need three properties. One to get and set the base value, another one to get the final value, one to get the number of modifiers. We will make separate functions for each of these, which we will implement in a second. And we also need a public property to give us the read-only list of stats that this stat contains. Let's create the set base value and get final value functions, but we will leave them empty for now. We'll come back to them in a minute. And let's implement the get modifiers count. This will need to return the sum of the modifiers count property from all the stats contained in our stats array. Now we can implement the rest of the properties required by the interface, and we can use the implement interface function of our code editor to do that for us. One of the things that we were missing were the properties from the multiple interfaces that return a read-only list of stats, and by choosing the automatic implementation, it knows that it should return our public stats property that we just made. Let's also make a constructor for this, and for input parameters we want a base value and an array of stats. But let's declare it with the params keyword, which allows users the option to input those stats as if they were individual parameters, or you can just pass in an array directly, that also works. This constructor is very straightforward. We just want to assign our class variable stats to the stats array that was passed in as a parameter, the class variable base value to the base value that was passed in as a parameter, our current value, since we are just constructing the stat at this point, will be equal to the base value, and we want to subscribe to the onValueChanged event of each stat in the array, but we don't have a function for that yet, so let's create it. This function will also be very simple. We will just set the isDirty flag to true, and we will invoke our own onValueChanged event. We don't need to calculate anything here, because the calculations for the final value will be done in the calculateFinalValue function, as you might have guessed. As a very tiny optimization here, we can cache the delegate for the onChanged function once, and then reuse that across the loop, instead of having to incur the cost of one allocation per registration. In case you didn't know, whenever you assign a function to a variable, which happens whenever you register to an event, or you pass a function into another function as a callback, whenever you do that, a new object needs to be created, which costs some allocations. So if you know that you're going to need to register the same function multiple times, you can save it to a variable yourself and incur the cost of the allocation just once, and then reuse that variable. Let's make abstract functions for add modifier, remove modifier, and calculate final value, because we want concrete implementations of this class to figure out how they want to do each of those actions. While we're at it, in the constructor, rather than assigning the current value directly to the base value, instead let's call this abstract function that we just made. For remove all modifiers, we just want to loop through all of our stats in the stats array and call their own remove all modifiers method, and we store the sum of the number of removed modifiers so that we can return the total amount that was removed. For a few of the other functions like clear and get modifiers, they're going to be very similar. We just want to loop through our stats array and call the clear method and the get modifiers method for each stat. In set base value, we check if the value that we are setting is different from the current base value. If it is, we set the isDirtyFlag to true, assign the new base value, and then invoke the onValueChanged event. For getFinalValue, we will check if the isDirtyFlag is true. If it is, we set it to false, and then we assign the class variable currentValue to the result of the calculateFinalValue function, which receives the base value as a parameter. At the end, we return the current value. We also need to make sure that the remove modifier method returns boolean and not void to conform to the interface requirements. Now I want to implement the concrete version of this stat class, but before we do that, I want to organize things a little. We will place all of the scripts that we have made so far into a new folder that we will call core, and we make a new folder called default, where we will place the concrete implementation of the stat class and the stat modifier data struct that we will be making in a minute. For the scripts that we moved to the core folder, we will move them to the appropriate namespace as well, so the namespace changes from rpg.stats to rpg.stats.core. Back in Unity, inside our default folder, we create a new class called stat. This will be the concrete implementation of the abstract stat class that we made just a moment ago. This class goes into the namespace rpg.stats.default, and we can also make the script for the stat modifier data struct that we need to implement as well. This one also goes into the rpg.stats.default namespace. It should be a read-only struct, and it needs to implement our stat modifier data interface. This struct needs to store the type of the stat modifier, but we don't have that yet, so let's create a new script for that, and inside that script we will declare an enum for stat modifier type. The values of that enum will be add, molt, molt total, max, and min. Back in the stat modifier data struct, we can declare a variable of stat modifier type, just called type, and we can also declare a variable of type object called source. We can also declare a private int variable called hashcode, where we will cache the hashcode of this struct so that we don't have to recalculate it every time it is requested, and we just need to calculate it once. This gives us a rather significant performance improvement when we are adding, removing, or retrieving stat modifiers from the dictionaries where they are stored. For the constructor, we just receive a type and an object parameters, and we assign them to the corresponding public variables. We should also store the calculated hashcode in our hashcode variable. For the compare_to function, we just compare the stat modifier types of both objects using their own compare_to method, but before we do that, we cast the enums to int to avoid the generic compare_to that receives an object, which would cause the enum variables to be boxed. Boxing is what happens when you convert a value type into a reference type, and in this case, an enum is a value type, since behind the scenes it's basically just an int, and an object is a reference type. Boxing just means that a new reference type object needs to be created to store the value type, and that causes allocations, which, if we can, we want to avoid. For the equals method, we just compare both the type and the source of both objects and see if they are equal. And we also need to implement the equals and hashcode overrides, and those are also very straightforward to do. The equals override will just check if the object is a stat modifier. If so, it will call the equals method that we just made, and the hashcode override will just return the hashcode that we saved in the constructor. Just for convenience, we can also implement the equals and not equals operators, and these also just call the equals method that we implemented, which receives a stat modifier data as parameter. Let's move on to the concrete stat class. This one needs to extend the abstract stat class, and the generic parameter will be the stat modifier data struct that we just made. In the constructor, we will receive a base value, and we also need an array of stats to pass to the base class. For this particular implementation, we will make a static function that allocates this stat array. This array will have as many stats as we have stat modifier types, and in order to generate them, we will make a for loop with a switch statement inside, and for each value of the enum, we will instantiate a different type of stat. For the add type, as you may have guessed, we want to instantiate a new SimpleStatAdd. For the mult type, counterintuitively, we also want this to be a SimpleStatAdd, because in this case we want the modifiers to stack additively, but later on, when we implement the calculateFinalValue function, we will use these additively stacked modifiers as a multiplier on our stat. For mult total, we want a SimpleStatMult, for max, a SimpleStatMax, and for min, a SimpleStatMin. We also set appropriate base values for each of these stats. For all the stats that will be used multiplicatively, the base value should be 1. For max, the base value should be min value, and for min, the base value should be max value. What that does is makes sure that when these stats don't have any modifiers added to them, they will not have any effect on our stats. And for additive stats, the base value should be 0. Now we just need to call our function in the constructor when we call the base constructor. For adding and removing modifiers, it's very straightforward. We grab the stat modifier type variable, which comes from modifier.data.type. We cast that to int to get the index of the corresponding stat in the stats array, and we add the modifier to the stat at that index. And for removal, it's the exact same thing, except we call remove modifier instead. We can't forget to return the value of that call, since that function returns a boolean. And for calculateFinalValue, here is where we apply a formula, if you will, adding, multiplying, or doing whatever else we need to do with each of the stats in our stat array to our base value in order to calculate the stat the way that we want to. For our default stat, we will add the final value of the add stat, we will multiply the value of the mult stat, we will also multiply the value of the mult total stat. Don't forget that these two are different. One of them has its modifiers stacking additively, and the other one has the modifiers stacking multiplicatively. And then for max and min, we call the max and min functions, using as parameters our final value and the corresponding stats final value as well. Alright, this is mostly done. There's just one last thing that I want to add to this system, but I will leave that for the next video. In any case, by the time this video comes out, there should be a link in the description for the full source code of the RPG stat system. The GitHub repo will include not only the new system, which you've seen throughout these videos, it also includes the old character stat system, it includes the performance scripts that we've seen in the first video, and it also includes many unit tests, which, if you decide to roll your own implementations of the classes shown in these videos, those unit tests might be useful to you to validate that your stats are working as expected. So that's all for this video. I hope to catch you in the next one.